Already we have learned the case testing. Already we have the concept of the case testing in one of our previous lecture, one of our previous video. So what is uses of it? So it is used mainly in hypothesis testing. It's used by simply by using hypothesis testing if two random variables are same distributions, have same distributions or not. So the case test mainly used the hypothesis testing technique. Hypothesis testing technique it used to determine if two random variables have the same distribution or not. As the actual is that these work are these things we have to find. That means we have two different random variables. If we interest to find these two random variables have the same distribution or not, we will simple you can use the QQ plot. Then in the QQ plot we need the computer help because to plot the things. But in case test without using the help of computer we can calculate easily from the case test the two random variables have the same distributions or not. Okay, so the case test is based on the uses of the hypothesis test. So let's try to understand the uses of this hypothesis testing in different examples. So here the examples that we are going to discuss: the designing the darks or medicine. Okay, the examples that we have taken here: designing the darks, designing darks or medicine. So let's see this thing in this field, how the in this field in medicinal domain how these hypothesis testings are used. Let's see this. Suppose let's take we have two companies, company 1 and company 2. Two companies we have. The company 1 are built the drug 1. The company 2 are built the dark and means drug 2. The company 1 built the drug 1 and the company 2 drug 2. Okay, and the dark one are already available in the market. This dark one, this drug one means drug. Okay, sorry for that. This drug one are actually available on market. Okay, it is already in market. This drug are already in market, but this drug too are new in the market that has been built by company. Isn't new. These things has been new in the market. The thing, the company that has tested that because these things are already available in market, the company has known that this drug 1 are reduce the fever in 4 hours. That's the data already known by company 1 because it is already available on market. By they have some experimented, the some patients are already used. Because from this data the company 1 know that this drug 1 are reduce the fever in 4 hours. It's reduce the fever in 4 hours. Suppose let's take let okay, the dark 2 that's new in the market. The company that built, they claim that, means they have claimed here, they claim that this track 2 will reduce the fever faster than D1. Means it's reduced in 4 hours. Now their company D2 that has the company C2 that has the dark D2 that they have built, they claim that this dark D2 reduce the fever less than D1. It reduces the fever faster than faster faster than D1. They claim this thing. They claim this. The company D2 they have claimed this. Now the tasks that have to design. The tasks that we have here. So what is the task? We have the task is we have to experiment tasks that we have to design. We have to experiment that to determine the claim is true or not. Tasks we have make an experiment. We have to make an experiment to determine if the claim is true or not. That has been claimed by company C2 or the dark D2. True or not? That's the job we have to do. This is the experiment that we have to make. Okay. Now for this experiment, the first thing that we have to do, we have to make a statistics. We have to make a statistics for this. So first let's try to understand what the experiment that we have to build here. Let's try to understand the experiment. So first experiment we have first experiment that we have to do, we have chosen 100 points. First thing that we will choose 100 peoples to test this, to make the participate on the experiment. 100 peoples we choose, 100%. 100% we will choose, and randomly we will select 50% from the dark one, and the randomly, and after rest of the 50% patients we will taken for dark 2. We choose randomly 50% for the dark 1, and the rest of 50% is used for the dark 2. So for dark 1, the sample that we have taken here, suppose let's take the sample for dark 1 that we have taken, let's call this is a S1 that we have taken for that dark 1. So here we have 50 patients, here we have 50 patients as kind of 50%. For this, the rest of the 50 sample, the rest of the 50 patients are called the sample 2. Sample 2. Okay, and this sample, now this S2 means this rest of the 50 patients. Here we have the rest of the 50%. This for this patient we will apply dark 2. arrow sign opposite means we will apply on for this patient, dark 2 will apply for. Okay, suppose after applying the dark 1 for this patient, suppose let's take the data we will got for patient 1, the fever reduces in 4.5. Suppose let's take it reduces 3 hours, such kind of data. Suppose let's take it reduces suppose let's take 3.5 hours, 3 hours, 2.5 hours. For that also data 2, for data 2 suppose let's take we got it's the 2 hours, it's we got 2.5 hours. So let's take we got 4 hours. So, okay, such kind of data we have collected from these two group of patients that has been randomly built from this set of 100%. Means 100% of same kind. First thing that we have to same kind means it will be same age group or same kind of biological structure it has. So the doctor has known this kind of. Okay, that means same kind of patients that have chosen 100%. And these two things, this means these things means if a 50th patient from sample S1 take drug 1, then fever reduces in 2.5 hours. This means this actually is literal meaning. Okay, same things also here apply. If the 50 patients from the sample 2 takes the dark D2, then this fever reduces in 4 hours. That's mean. That's the first experiment that we have to do. So after doing this experiment, we will calculate its mean. We have to calculate its mean. Suppose let's take the mean we have calculated here, it's mu1. Suppose let's take for this sample 1, it's mean that we got 4 hours. 4 hours that we got. Okay, this is the mean time for sample 1. This is the mean time for sample 1. Okay, and similarly also here we will calculate this mean. Suppose let's take we got its mean is equals to mu2, that's is equals to 2 hour that we got here. Suppose let's take let this is the simple mean time for sample S2 means we will apply here D2 dark, here we will apply here D1 dark. Okay, dark. Now this is the first experiment that we have to make. So after calculating the mean, this means from the observed value, these means are actually the observed value. After calculating this, we have make some hypothesis test. We have make some hypothesis statistics, means test statistics we have to design. In the hypothesis testing, the first thing that we have to make after calculating these things, or the have to make the we have to make the null hypothesis, means we have make some assumptions on it, means we have to make some assumption. We have make some assumption. Suppose let's take, suppose let the assumption that we have make here, the D2 dark D2 and D1 dark D1 take the same time to reduce, means they have no differences, that we have assumed here. Take same time to reduce the fever. That's the assumption that we make here. Okay, the first thing that you have to do. Now in secondly, second thing that you have to do, you have to make this test statistic. We have to make the test statistic. So what will be the test statistics here? What will be the test statistics? So we have to make the test statistics, the difference of the mean of the observed value. So what is the mean? Mu1 and mu2. We have to make the difference, and this mean actually what? This mean the observed mean, means we will apply the randomly selected 50 peoples, okay, and we apply D1 and we will find this observed mean. This is the observed mean that we got. Okay, so let's take, we will calculate it, mu2 minus mu1 means difference of the observed mean. Okay, this is the observed mean for the dark 1 and this is the observed mean for the dark 2. And here we got this value is what? Mu2 is how much? Mu2. How much mu2 will get here? Mu2 is 2 hours. Mu1 is 4 hours. Suppose let's take for easy of calculations mu1 minus mu2, because mu1 is greater. Suppose let's take it's the mu1 minus mu2, because I want to make it positive. Because of that, you can, if you interested, you can take mu2 minus mu2. According to that, we have to build there this kind of calculations. So suppose let's take, we have mu2. We will got the statistic value 2 hours. This is the observed mean. This is the simple observed value. Call OBS. We call in short OBS, observed value. That's the first thing that we have to do. Now after calculating, there we will already seen previous video how we calculated using permutation test, how we calculated the p-value. And so we have to calculate the p-value, the test statistics, how much it will be greater than or equals to 2, on the basis of our assumptions H0. That's thing we have to make, we have to calculate. These things means what? These things the actual the observed value. These things means actual the our assumption. These things are actually our assumption. If this value is very small, if this value is very small, if this value is very small, suppose let's take its value is 1%. Suppose let's take very small value. Let this thing is very small. Okay, that means what? That means if you write this thing in English, if you write this thing in English, then what will get? In English literal meaning is if there have no difference, if there have no difference in these two medicines, in the medicine 1 means drug 1 and drug 2, then the probability of observations the observed x greater than is equals to 2 is very small. It's very small. Means here I have taken here examples. As an examples I have taken here 1%. It is very small. That means what? That means on our on the basis of our assumptions, means we have assumed that d1 and d2 are there have no difference, and on the basis of that assumptions we make these observations, we make the observed value. This observed this we on the basis of that we will calculate this statistics value, and on the basis of that observations we find that this p value, this thing means simple, this is the p value. This things means this is the simple p value. This p value. Okay, on the basis of these assumptions of p value, this means our h naught or null hypothesis, our assumptions and our observations do not agree each other, do not accept each other. Do not agree each other. That means that implies that what? H naught, it must be incorrect. Must be incorrect. That thing must be incorrect because only this, because of that, because it's do not agree each other, because of we got this probability value, this p value is very small, these things. Now the third step, that's in the second stage for the test statistics, and we have to find, somehow we will to find this p value. That's the technique we have. Okay, now in third step, we have consider the significant level. Okay, if I want to find the actually this is the medical domain, means their significant level is very important. Here the significant level is very important in medical domain, because these things are actually depend on domain to domain, because we have this is the live taken matter for these examples, so we have to make very sure for this. So for these situations, for to sure these things, I have to take a right significant value in such situation. Okay, so I want to very sure, I want to very sure that very sure when I reject a null hypothesis, means we have rejected a null hypothesis, we must be very sure. 9, reject the null hypothesis means we have, when we reject our assumptions. Okay, that's thing that we have to make. So in such situations, in such domain, we will choose very small, means small alpha value. So we'll choose in general medical domains, we'll choose 1% significant levels, very small. So, or somewhere we will see when somehow it will be 0.1%. Means when we will very sure. Means what? This means we will very sure about our hypothesis. Only then we will consider. Okay, very small value. We will choose very small value for the significance. But this depends on the situations to situation. So if so, we'll see if for p value is less than alpha, means the small alpha, then if this small alpha, then we reject. Then we reject our null hypothesis, else we accept it. Else we accept the null hypothesis. That's the job we have to do. So that things are depend on the situations to situations that already we have seen. So that's the things, but I think we will understand from these examples in the domain is how matter the hypothesis testings, the significant levels that we have choose that's depend on our problem based on our situations, based on our problem. Okay, if you just consider this same, if you just apply the hypothesis testing, suppose let's take we apply the hypothesis testing in e-commerce. In e-commerce we'll apply the same thing, hypothesis testing, suppose like in a, suppose let's take in e-commerce website, in e-commerce domain. In e-commerce domain, if we apply this thing is there. So in such scenario we have to choose, in general we will see things 3% or 5% significant level. We will choose this kind of significant level in such kind. Suppose let's take I've taken an example. Suppose I have a sample. We have a sample that suppose we have a customer, such kind we have a customer, we have such customer who will use who is visa card, and also we have some customer who will use mastercard. Okay, now our claim is that who will use the e-commerce, the visa card users or mastercard user. We will use the visa card, the most e-commerce website, means in the e-commerce website. Suppose let's take, I think if we going to more specific, then I think it will be better. Suppose let's take the Amazon India, Amazon that's want to get the answer, the which kind of users are use most Amazon, most e-commerce website, means the visa card users or mastercard. Okay, that's the answer they want to get. So in such scenario what will happen? So the from randomly we can easily for the visa card company, they have some customer. For the visa card company, they can randomly choose some customers and they can calculate it, their demand for this. Suppose let's take the company that have built the visa card, they randomly choose sub customer, and they look that the customer they use the visa card, they mostly use the which website in e-commerce, in which website. Suppose let's take the mean that we got, suppose mu1. And similarly for mastercards, the mastercard users, the users who are using the mastercard, so in which website they will prefer, in which e-commerce website. Okay, so this mean they will got mu1 and mu2. And the test is that, now our test that we are interested in doing here, so is there differences, is the each large or not, is mu differences of mu1 and mu2 is large or not. If it is large, means there have some more differences on visa card users, means the mastercard and visa card users are different, the different type of e-commerce website. If this difference is smaller, means there have no some differences, means any card users can use any kind of e-commerce website. That's kind of answers one to sometimes the e-commerce companies want to get such kind of answers somewhere. So I think from these explanations, from from these examples made from the examples of the drug designs, you will get the more clear idea of the hypothesis testings, how these things are actually workable in real world. And when we perform the case studies, then we will see how these things are you actually work to make some primary decisions in the machine learning. We will see these things when we will going to the case study portion.